A stone is thrown vertically upwards with a speed of 14.7 meters per second from a point A which is 49 meters above the ground. Find the time taken for the stone to reach the ground. Calculate the speed of the stone when it hits the ground. So here's the picture of the information we've got. It's 49 meters above the ground. So let's just put that in. And it's thrown vertically upwards with an initial speed of 14.7 meters per second. Here's the question in summary form then. So A, find the time taken to hit the ground. We know the acceleration because the acceleration is downwards with a g due to gravity. So, okay. So, what formula shall we use? We've got v squared equals u squared plus 2as. We know the s and we know the initial velocity, but we don't know the final velocity. We know v equals u plus a t, and then we also have s is equal to ut plus half a t squared. So this looks more promising, doesn't it? Calculate this, find the time taken to hit the ground. S will be minus 49. So here, minus 49 then. If we're looking going upwards direction, this is minus 49 distance is equal to the initial speed, 14.7 times time, plus a half. In the upwards direction, it's minus 9.8 over 2 is 4.9. T squared. So that tells us then, move this over to the left hand side, 4.9 t squared minus 14.7 t, move that over there as well with a minus, minus the 49 that's already there. Now we solve the quadratic. Minus b plus or minus the square root of b squared minus 4 times a, 4.9, times the c, which is minus 49, all divided by 2a. So that's 2 lots of the 4.9. So let's type that in the calculator then. So we've got 14.7, so put a bracket around the top numbers, 14.7 plus the square root of 14.7 squared plus 4 times 4.9 times 49. Come outside the square root. So that's the top number then. Close that bracket, divided by 9.8 equals, we get 5. But if we get the other value, so if we scroll back and change that plus to a minus, then we'll get the other value of the root. Just to have a look at that one. Minus, and we get minus 2. So clearly the minus 2 is not suitable, so t equals 5. Okay, that's part A, that's the time taken then. Calculate the speed when it hits the ground. Well, we can use v equals u plus at, can't we? So here, this is part B. V equals u plus at gives. So the final velocity is equal to the initial velocity, 14.7, times the acceleration, which is minus 9.8, times the time, which is 5. Okay, which is 14.7 minus 10 is 98, so this is 49. So the velocity is minus 14.7 takes 49. Take away 49 is minus 34.3 meters per second. So answer then, the speed when it hits the ground is equal to 34.3 meters per second.